Now we have the fourth classification of polymers, which is done on the basis of formation. So on the basis of formation, we can divide them into two categories: addition polymers and condensation polymers respectively. Now let us start with addition polymers and see it in detail. So addition polymers, as the name suggests, will be the polymers formed with the help of addition of monomers. So suppose, taking an example, that we have CH double bond CH, and let us say we have a group attached to this C over here. When we take n number of these monomers, so these are the monomer units as we know, and we have discussed it already. So monomers on polymerization, we know monomers on polymerization give us polymers, and when we draw the polymer of this particular monomer, it will be something of this sort. So we have got n units of this polymer over here. So as we can decipher that monomers, when we kept on adding this particular monomer to itself again and again, we get the certain polymer that we are looking at. A few points that we have to keep in mind over here. The first one is that there is no loss in mass. And what do we mean by that? That the mass of polymer, the mass of polymer, when we begin to find the mass of polymer, it actually turns out that it is the summation of the mass of monomers. So imagine that we have taken 8 monomers, then the mass of the polymer will be 8 times the mass of the one single monomer. So there is no loss in mass. The second point that we have to keep in mind over here is that there is no elimination. There is no elimination of smaller particles. So the product form, that is the polymer form, will be not be an there will be no elimination of smaller particles when we have this certain polymer being formed. And what are the smaller particles? It can be water, alcohols, okay? And there will be no elimination of these smaller particles. So these 2 points we have to keep in mind, and we have done a couple of examples of addition polymers already. And if we have to write examples of this, we have already covered them. So polythene, which we saw, was formed with the help of monomer ethene. So ethene on addition to itself gives polythene. Okay, so you can see that there is one other example. So we can form polyprene with the help of propane, polypropene, and there are some other examples of this addition polymers. Now, the second category that we see on the basis of formation, the second one is condensation polymers. Okay, so condensation polymers. Now, condensation polymers, let us begin with by taking an example. So we have already seen an example before, that was nylon 66. So refreshing a memory over here, let us take this hexamethylene diamine over again. So we have got CH2 whole 6, then we have got NH. Now I'm writing the H like this, and we have got C double bond O H, and now here we are taking CH2 8. Okay, so instead of we had 4 here before for nylon 66, now we are moving on to this one. Now as you can see, what will happen is that this H will be lost from over here, this OH will be lost from over here, and when we begin forming the products will look something like this. So we'll have N with an H. This is coming from hexamethylene diamine. Okay, let us just name them first. So these are monomer units. So this is hexamethylene diamine, and we are combining this is known as sebacic acid. So when we combine these two, there is a loss of water molecule which is occurring, and now we'll have a polymer which will be developed, which will look something like this. So CH2O6, then we have NH. Now it has lost its CO. So let us just draw it in this manner. So let us put N, H on the downside with C double bond O coming from silicic acid, and the rest of the carbon follows suit. So this is C double bond O. Now we have already seen that during the elimination of water molecule, when there is a linkage, a peptide linkage being developed, this particular OH is also lost, and what happens is that the chain opens over here. So now we have got ourselves this chain, this polymer over here, n units of this, because initially we took n units of both of them. So the name of this polymer that is in front of us is nylon 610. 10 because there were 10 carbons that we took from this place. So 8 carbons were here and the 2 carbons were here. So there were 10 carbons in this place and 6 carbons came from here. So this is known as nylon 610. Now this nylon 610 is actually a polyamide. As you can see the amide linkage over here. This particular linkage is known as the amide linkage, as you are aware of, NHC double bond O. So because of this linkage, we call this a polyamide. Now, here you can see, if we are asked that whether this is a homopolymer or a copolymer, we can easily say that this is indeed a copolymer because it is formed by the two monomer units that we took. So this is a copolymer. Next, if we are asked whether it is an addition or a condensation polymer, so it is a condensation polymer, and that is because there is a removal of water molecule. Next, if we are asked whether it is a linear or a branched polymer, we call this a linear polymer, but there is cross-linking happening and there is a development of H bonding that you can see over here. So this is in, but this is called a linear polymer because it is a straight chain polymer. Next, if you're asked whether it is a natural or a synthetic polymer, because this is man-made indeed, we're combining two polymers, two monomers on our own, then this is called a synthetic polymer. So we can classify it like this. Now, if we have to see certain properties of this condensation polymers, here we see that the mass of polymer that we obtained, so mass of polymer that we'll obtain will be actually less than the sum of mass of monomers. And why this is so? Because there is a loss of water molecule which was occurring. So eliminated molecules are obtained over here. So eliminated molecules, now eliminated molecules we can have ROH, that is an alcohol. Then we can have a lot of eliminated molecules. So they are small molecules like water. Then we can have HCl. Then we can have NH3 or CO2. So molecules like these are eliminated to give us these condensation polymers. Now, if we see what are condensation polymers now, so condensation polymers are those polymers which are formed by joining of smaller units of monomers and also involve the elimination of smaller particles. Okay, so we can say that they are formed by joining of joining of smaller units of monomers, but you have to keep in mind that there is elimination. So there is elimination of smaller particles. Now we have to keep this in mind. And smaller particles, we have already highlighted a couple of them. So they can be ROH, H2O, HCl, NH3 and CO2. So this is how condensation polymers are formed, and here we have already seen that the mass. So in addition polymers, we saw that there was no loss in mass, and here loss in mass is occurring. So there is loss in mass, as we've already seen that the mass of the polymer over here is less than the mass of the monomer. So we have to keep these certain points in mind when we form the condensation polymers. Now, similar to nylon 610 that we discussed, we have the nylon 66, which we have already seen, and these are some of the condensation polymers.